Okay, so this is going to be a review of Newton's laws. Hopefully you guys remember something about that. Remember that there are three laws that we have to talk about. The first two are pretty simple. Basically, the first one says that, if an object in motion tends to stay in motion unless yada, yada, yada. Okay, basically what the first law says, it answers the question, what is a force? Okay, we have that question. What is a force? Well, if you have this object, let's say it's a marble rolling across the floor, it's going this direction. Okay, if it's going at a constant velocity, so we're going to say it's going at a constant velocity, then what's going to happen to it? Well, it's just going to keep rolling until it finally, hits a wall over here, doink, it hits the wall, and then all of a sudden you have a velocity equal to 0. Okay, what if you want it to turn? Well, if you want it to turn it, then you'd have to give it a little bit of a kick that direction, and it would go in another direction. Okay, if you just wanted it to sit there, let's say we have the marble and it's just sitting there. Okay, you don't have to do anything, it just sits there. So what the first law says is basically if you want to change an object's motion, and emphasis on the word change, if you want to change an object's motion, then that's when you have to have a force. And a force is a push or a pull, something that can affect the object and how it moves. So, if you want to change an object's motion, you have to have a force. So that's the answer to what is a force. It is something that is needed to change an object's motion. Get it to speed up, get it to slow down, get it to change directions. Excuse me. It's just any kind of change. Okay? Get it to start moving, get it to stop moving, anything like that. So that's Newton's first law. Newton's second law asks the question, Newton's second law has an equation, force is equal to mass, yada, yada, yada. So basically, Newton's second law says, not W, how. How much force? Okay, that is Newton's second law, is how much force. So what does that actually mean? Well, if you want to speed up an object, let's say something is going from 2 meters per second to 8 meters per second, and you want to do it relatively quickly, let's say we'll do it in 2 seconds, well, you have to have a force. You have to have something that is pushing on that object, causing it to increase in speed. And that increase in speed comes out to be change in velocity is equal to 6 meters per second. That change in velocity over the amount of time, you have 6 meters per second over 2 seconds, and all of a sudden you have 3 meters per second squared. Okay, so there's our acceleration. We know what the acceleration is. It's change in velocity over time. Well, we have our object here. Let's say it's 2 kilograms of mass, and so if you do that, 2 kilograms of mass multiplied by 3 meters per second squared, then you get this number. You get a 6, right? 6 what? 6 kilogram meters per second squared. But this right here is really, really laborious to write all the time, so we just say, hey, it's 6 newtons. Okay, so a newton is a kilogram meter per second squared. So what all this is saying is that, hey, you take your mass, you multiply it by the acceleration, that gives you how much force that you need to get that object to change its motion. So how much force? Well, that force is equal to mass times acceleration. So what exactly is mass? Well, mass kind of comes back up to here. Mass is another word for inertia. Inertia is just talking about how resistant is it to change. That first example that we have is if we have this ball and it's traveling at a constant velocity and you want it to stop, well, you're going to have to apply a force. Well, that force is going to depend on how massive that ball is. If it's 2 kilograms, then you don't need a whole lot of force. If it's 2,000 kilograms, you need a lot more force. If it's 200,000 kilograms, then you're going to need a super amount of force, right? So that mass is just telling us how hard is it going to be to get this thing to change its motion, to get it to start moving, to get it to stop moving, anything like that. So mass and inertia are the same thing. Okay? If you wanted to measure an object's inertia, you would measure its mass. The last thing that we deal with Newton's laws is he's got a third one. And I'm sure you guys can recite it. For every action, there's an equal, and yada, yada, yada. We're talking about force pairs here. Force pairs. Basically says that if I hit you, then you hit me back. Okay, that's it. Basically, you can't touch something without it touching you. That's really what's going on here. So let's say you have an object that is, let's say it's hitting a wall. We'll go back to that one. So we have the object, it's rolling, hits the wall. So the object exerts a force on the wall, we would say. That is the force that is exerted on the wall. But equal and opposite, the wall exerts a force on the ball in the opposite direction that it's moving, and those two forces have to be equal to each other. That force has to be equal to this force here. Okay, but they're opposite in that they are in opposite directions. All right? So that's what force pairs are. Now you want to be very careful about force pairs because it gets kind of hairy when you're talking about things like gravity. Okay, if you are exerting, let's say here's you, right? Here's the Earth, right? Now we know that you're on the Earth. That's fine, whatever. So the Earth exerts a gravitational pull on you, right? This is the force of gravity. Okay, what is the force pair to that? Well, you're not really touching the Earth. You're exerting a gravitational pull, where the Earth is exerting a gravitational pull on you. So you're not really touching it, but there's still a force pair involved. That force pair is your gravitational attraction, or gravitational pull on the Earth. Now, which one's bigger? Well, according to Newton's third law, the force of gravity that you exert on the planet Earth is the same as the force of gravity that the Earth exerts on you. But if we take a look at Newton's second law, which one has more mass? Well, obviously the Earth has got way more mass. So even though you have the same force, since the Earth has a way more mass, it has a very, very small amount of acceleration. While you, on the other hand, have a pretty small mass relative. For the same force, you're going to have this bigger acceleration. And that acceleration, if you recall, is 9.8 meters per second squared. So just to recap everything, Newton's laws, we have the first one. What is a force? It's the law of inertia. It says an object in motion stays in motion, yada, yada, yada. It just says you have to have a force to change an object's motion. The second law, how much force? Answers the question, how much force? If you want to change an object to make it go faster, slower, change direction, you need a force. How much force? Well, that equation right there will tell you. Okay, and then our last one, the third Newton's law, is force pairs. If you have an object exerting a force on another object, then that second object will always exert an equal and opposite force back on the first. Okay.